Hello everyone, welcome to today's H1 Pro 3D scanner live stream. I'm your host Farah from VoxMeta team and I'm super excited for today's live session. Many of you have already backed the H1 Pro on Kickstarter and shared how you plan to use it once our scanner arrives. After reviewing your feedback, we found that many of you are working toward similar goals: automotive reverse engineering, digital archiving, replacement part production, and the scanning of mechanical components ranging from small details to large body panels. Today we want to connect those real use cases with live stream demonstrations. We've prepared 6 different parts: a front vehicle panel, a vehicle tailgate, a wheel, a torque link, and a set of 3D printed screws and threaded parts. For each part, we'll share a related question or use case from an H1 Pro backer and show how it connects with the actual scanning workflow. The goal is to give you a practical preview of what you can do with the H1 Pro once it arrives. So let's get started. So we start from our first case, the question from Brandon. Brandon says, I really just want a dependable, not beginner unit for hobby and small scale replication of car parts. I still have to learn all the softwares, so any tutorials for a complete noob would be awesome. So regarding Brandon's question, before we begin scanning, Brandon told us that he is new to the software and would like tutorials that start from the beginning. The basics VoxMeta workflow includes creating a project, selecting the appropriate scanning mode and parameters, capturing the part, removing the unwanted data, generating the mesh, and exporting the result for the next application. During today's live stream, we'll show these key steps as we work through the different parts. More advanced operations depend on the final goal, because inspection, reverse engineering, digital archiving, and replacement part production do not use exactly the same workflow. We have already published some basic software tutorials and will continue adding application-focused tutorials and live demonstrations. Now let's begin with our first part. So we move on to the next application case is from Murray. Murray says, Hi VoxMeta team, I'm a privileged hobbyist and small-scale industrial operator. I expect that I'll be using the H1 Pro primarily to contribute to a digital archive of scale models for hobby purposes and to scan hand-built prototypes of automotive subjects like modified body panels and bumper clips, or more mundane prototypes of external rear vision mirror bodies and mounts, for example for conversion to parametric CAD models in industrial contexts. So regarding the Murray's question, let's start with this front panel. Okay, we have here front vehicle panel here. You can see. So this would be our first object to scan regarding the question from Murray, right? It does contain tons of difficult geometry and details. It has some reflective and black parts. So we start from scanning this one. Okay. So first, when you connect your scanner to your PC, you want to go to the main page and first of all, you want to conduct the calibration. So anytime you want to start scanning, the first thing to do is to conduct the calibration. If during the day you have already did the calibration once, you don't need to do it again. You can do it the next day or after 2 days maybe. So let's go and choose the calibration mode here and just follow the instructions inside the program. Project, we will come to the main page. Here you can see we have point spacing option. It does determine the quality of your scan, how much details you want to capture. So by default we have 0.5. If you want to achieve a better result, you want to put it to 0.2, 0.3 or 0.1. And we have laser modes, 3 laser modes: cross-line lasers, parallel lines, and single laser mode. For this case, we're gonna be using 34 cross-line laser mode to scan this object for fast and wide coverage scanning. Also, we have scan object mode, we have normal mode, dark mode, highlight mode. So according to the object you're scanning, you want to choose one of the 3 options. For these options, for this object, although it does contain some black and reflective part, we're still going to be using normal mode. And during the scan, we can adjust we can check whether the scanning is good or not. And according to the results, we can change the level of exposure. It's here, shutter. Shutter is also exposure. Here it is by default set to 0.5. So we don't change anything here. We just move on to scanning the markers. As you can see, I have placed markers on the surface, so we can start by scanning the markers first. Murray plans to scan automotive body panels and other exterior vehicle parts for reverse engineering and CAD reconstruction. He also asks how these surfaces should be prepared to achieve a better scan results, especially when they are dark or reflective. In most cases, the H1 Pro can scan dark, moderate, reflective surfaces directly without scanning spray or other surface treatment. For highly polished, mirror-like or transparent surfaces, scanning spray may still help improve data quality. As you can see, we are scanning this panel directly on its original surface. We'll cover the main surface first and then complete the edges and curves. During the demonstration, we're looking at tracking stability, scanning efficiency, overall data completeness, and how the H1 Pro handles the surface directly. So let's jump into scanning, right? Every time you scan a new object, we'll recommend to you to quickly conduct scanning the markers first for stable tracking. Alright, after that, long press on play button and double tap on M and you switch to point cloud scanning. For this object, I will increase the exposure level, let's say up to 1.5, and let's see what kind of result we can get. Right, as you can see, the scanning process is really smooth and fast. Currently we're using 34 cross-line laser mode. Let me zoom in so you can see better. Alright, so we first scan the main body. Quickly, you can see these reflective parts. All right. So we will scan the main surface first. The higher the exposure level, the better you can capture these dark and reflective parts. Alright, now I've finished scanning from this side. I want to go to the front side, so I want to capture the parts that are not visible from one side. So I change the angle and try to scan it from this side. So as I said earlier, we have 3 scanning modes. There is 34 cross-line laser modes I'm using currently. You can see it is designed for fast and wide coverage scanning for bigger objects. Also we have 17 parallel laser mode for fine details and surface texture. And finally, we have a single laser mode single laser mode for deep holes and narrow slots, the places that are not easy to be penetrated. So according to the object geometry and complexity, you want to choose the scanning mode. Also, you can combine them. You can switch between the scanning modes during the process. You don't have to restart anything. You just want to pause and change the scanning mode by double tapping on the play button. I think we have finished the scan. Now let me check it out. Now let's see the scan data on the computer, and we can review the overall coverage and take a closer look at the dark and reflective areas, right? So here we have our object. You can see we have pretty much captured everything on the surface. Well, now we're going to move on to the next step. That would be the cleaning our mesh, our model. So we choose remove plane. So program automatically identifies the plane and the object, and just like this, you can just simply remove the plane. Also, we can use this connected items option in order to choose our object, and reverse choose, so we can delete these unwanted not connected parts. We just simply delete it. And now you can check the results. You can see how beautiful the scan is. Just check out how accurate and precise and clear and clean the mesh looks. Now this is our object, and now let's go to the final step, that is meshing. Let's choose. We have several options here. You can choose any one which you like, closer to reality, higher option, smaller size, or smoother. Let me choose for this one a higher quality and check out what kind of result we can get from car panel, a vehicle panel scanning. So this was the case of the Murray. So he asked, he plans to scan automotive body panels and other exterior vehicle parts for reverse engineering and CAD reconstruction. He also asked how these surfaces should be prepared to achieve better scan result, especially when they're dark or reflective. As you can see, we have covered this question. Now we have dark and reflective object that we have scanned using a higher level of exposure in this case, and you see that we don't have any noise nor other problems with our scan. And now you can check out how beautiful it looks, how clean and complete. Just look at this scan. Just beautiful result. In a matter of 2 minutes, we have managed to complete this almost 1 meter long scan, and this would be a fantastic result. You can check it, guys, how beautiful it looks. You can see all these hidden pockets, transition points. All these geometries are just perfectly captured. Also, we have these holes here. You can check it out. Everything looks perfectly beautiful. You can have a better look at this. Take your time, guys. So this was the vehicle panel, and now we can move on to the next case. Next case, we have our next backer, that is Bill. Bill says, hello, I intend to use the device to scan machined and cast components with largest physical dimension larger than 1 meters. Also, I intend to use the device to scan plastic composite open wheel race car body panels and body sections and golf cart bodies. My effort is primarily DIY. Alright guys, so for Bill's case, we have a very nice object here today. We have a vehicle tailgate. So we remove our vehicle panel to the side. We have already finished scanning this one. So we would need a bigger spot for our next object, because this object is larger than 1 meter. And here you can check it. Here we have this one. Let me adjust the PC position real quick. All right. So this would be our vehicle tailgate. Bill told us that he wants to scan machined and cast components with maximum dimensions below 1 meter, together with plastic and composite race car body panels and body sections. This tailgate is close to the type of large automotive application. For large part, accuracy alone is not enough. The scanner also needs to cover a useful area in each pass, maintain tracking while the operator moves around the object, and collect data efficiently across the whole part. The H1 Pro provides a maximum scanning area of 520 by 510 millimeters, and its 34 crossline laser mode is designed for fast coverage with scanning at up to 100 frames per second and up to 4.4 million points per second. We'll begin with the large surfaces, then move around the part to capture the edges, openings, and constructional transitions. So let's just move into it. All right. Here we have our object, and now let me create a new project. Let's save this one. And again, we start, we're not going to be changing anything here. We start by scanning the markers, guys. Let's just do it. As you can see, I'm still using the wireless mode. I have the H1 Pro does provide hot swappable battery system, so we can work wirelessly and have a total freedom of movement while scanning. All right, finished. Point cloud scanning. Let me check the exposure level. It's up to, let's set it to up to 1.5 and see how the scan goes. Okay, let me zoom in. This part is also quite reflective one. But as you can see, the H1 Pro does not face any challenges with this one. It just easily captures everything. All right, the scanning process is really enjoyable, primarily because of the scanning speed, right? So we have 120 FPS scanning mode. Of course, in order to achieve this performance, you need to have a proper PC specs. So the minimum requirement is Core i5 12th generation paired with video card RTX 2060. This is a minimum requirement. And the recommended requirement would be Core right, so we almost there. This is quite a big object. All right, yeah, we finished. We finished with this one. And check out the results. All right, let me check if we have any spots that we missed. I can see that everything looks very complete. This part is damaged because this car tailgate got into a car accident, so this one is damaged and we're not being able to scan it fully. We don't need to scan it fully because this part is practically useless, right? So we have question here is when you talk about poorly applied markers, do you mean the adhesive not pressed marker distorted or the position of marker too close to an edgy other markers? So that's a very good question. Both of your statements are true. I mean, when I talk about the poorly applied markers, I mean the not pressed markers that float above the object. Sometimes this also can cause the holes on the object. Also, I mean the marker position is too close to the edge, or on it is applied on some of the non-applicable spots, right? Let's say there is an edge and you apply it on the edge, so the program can't identify it as a proper marker. So in this case, you want to remove the marker and place it to the proper places, and you don't want to put it on the edges and other difficult on top of the other difficult geometries, right? So both statements of yours are true. Now let's remove the plane from our object. So we choose 3 dots on the surface. As you can see, program separated our main body from the surface. And now we can delete this unnecessary data and use associated point cloud option, choose our body. Let's say we don't need this one and we need this one. We choose it and we do reverse choosing and simply delete all the parts. Now we have clean data, and now we can check it out, guys. This one is car tailgate. It's quite a big object. Now you can check how accurate the scan is. So let's go and mesh it up and check the final result. All right, so any questions you guys have, you can ask in the chat. We'll try to answer to you timely. Also, don't forget to mention on what project are you guys working on currently. You can share on the chat. We'd like to see. That is very interesting topic. So if you're working on some projects, you can mention them in the chat. So we have our scanner in a wireless mode currently. You can see it is very convenient to use. It is really easy to move around the larger, especially larger objects like this on your workstation. So you're not gonna be worried about getting tangled by the cables or other stuff. So you're not connected to no device with the heavy thick wires. And now you can check the meshed result. You can see our program, how fast our program is. That's complete such big data optimization in a matter of a short period of time. And you can check these holes. Beautiful result. Super satisfied. So this is the damaged part of the tailgate of the car. I didn't capture the interior part on purpose. It's not necessary. It's not going to come out clean because it is very deep inside. So although we can still reach there, it's not necessary data, so we leave them out. Other than that, all the surface visible spots are beautifully captured. You can see this spot. So you guys can give your score for this object from 1 to 10. I'm sure most of you guys will give it somewhere between 9 and 10. And I'm not exaggerating. You can check how beautiful it looks. Yeah, so this was the case of the bill. This was the second case. And now we can move on to our next case, that is Earl. Right, so we have finished with this one. If you have questions regarding to this use case, you can ask in the chat also. We're very glad to answer to you guys. So Earl asks us, hello, I plan to use this scanner for personal DIY stuff, like scanning figures to make STLs to print. Also, I want to scan my car to be able to design parts for it along with doing SFD. Another hope I have is to be able to scan my wheels so I can supply the file for a wheel manufacturer to change the diameter and width. Any demonstration you can do would be great, as I have never had a scanner before. Alright, so this is the case of Earl. It's our third project for today. So in this case, we're gonna be using, let me remove this big guy from here. Does take a lot of space. Alright, next one. Next, we'll scan a wheel. Earl gave us a very specific use case. He wants to scan his wheels and send the geometry to a wheel manufacturer so that the diameter and width can be changed. He also plans to scan his car for custom part design and SFD work. A wheel is useful for showing the difference between simply capturing an object's outer shape and collecting data that can support later engineering work. We need the overall diameter and width, but we also need consistent geometry around the spokes, openings, rim edges, and curved transitions. The H1 Pro offers accuracy of up to 0.050 millimeters. We'll use the fast scanning mode to establish the overall wheel geometry first, then add more details in selected areas where needed. So let's jump into it. All right, let me use some cards here in order to create a plane and just start scanning. We create a new project here. So for this one, we would like, there is some writings and small surface details on this object, so we want to capture it, and in order to do this, we're going to be increasing our detailing. That is to say, the point spacing, right? In this case, we're going to set our point spacing, let's say up to 0.25. 0.25. We're still going to be using 34 crossline laser mode, and we're going to set shatter to 1.5, right? So let's start from scanning the markers. So we have question here. So how big is the file size for the items you have scanned so far? If you're asking about the biggest file scan, biggest file scan, I remember we have scanned the car, almost the whole part of the car, and it was around 5 gigabytes, I guess. And usually when you scan the size of this guy's size, for example, this will be around 400 or 300 megabytes, so it's not a big data, although the data is big, but the size of it is not big when you export it out. So let's start from scanning the markers, guys. Okay, I can see that we have not enough markers on the object, so we will apply some more by just simply adding more markers. And later, if you notice some problems with the holes because of the incorrectly applied markers, we can change them by just removing it from that incorrect place and putting it on the accurate place. So here and also here, you can see we have a lacking spots like this. Now let's just continue scanning the markers. Alright, we have finished scanning the markers. Now we can move on to scanning the object. exposure up to 1.5, and when let's start. The higher the resolution, the lower the speed. So if you want to compensate the speed, you want to increase the level of exposure, but not too much, because you might get some noise. So it just depends on you. You just want to experiment and check which parameters fit perfectly for your object. So this is not a catastrophe, even if you choose incorrect parameters of the scan. So the main thing here is experimenting and finding out which one suits best for your case. Okay. Due to the fact that we have Wi-Fi 6 and Bluetooth connections, we have a stable wireless gigabit transmission. That's why we can achieve this high level of wireless connection without any cables. Also, you can see that we're not experiencing any kind of noise, any other issues here. So any questions, guys, you can ask. Also, don't forget to subscribe to the channel. We have new projects coming ahead. So if you're into 3D world, you might want to hit that subscribe button. All right, we have finished almost the half of the scan. Let me come here and check how it's going. So the usage of the program itself is extremely easy and simple. Once you put your hands on the scanner, once you get the scanner for yourself, once you open the program, you will notice that all the instructions, all the options are very simple and easy to understand. So it's beginner-friendly program. I'm sure none of you will experience any difficulties with using our VoxMeta program. All right, I have finished, I can see, but I want to run it one more time and to catch the spots that were not completely captured. Right now I can see we have a beautiful scan. We can pause it or just finish the scan. You can see the overall wheel geometry is now established. Here we can review the wheel geometry, including the rim, the spokes, and openings, right? So as you can see, the point cloud optimization takes a little more time than usual because we used a high density of points, right? So that's why it will accordingly take some little more time. Now you can check how the small writings, small details are all visible. on the surface, all the logo. We can see the spikes here. You can see after scanning, the data can be imported into Polyworks or other measurement software to measure dimensions such as the diameter and width, or perform further dimensional inspection. The point cloud or mesh can also be processed in reverse engineering software to provide a geometric reference for wheel modification and cab reconstruction. So here we have it. Now let's go and clean it up. We have plane here, just simply delete it. Also choose this option to clean it up. Okay, inverted choice, just simply delete it. Now what you want to do is, let's go mesh it up. Let's go mesh it up. This is our third case. The H1 Pro delivers up to 4.4 million points per second. H1 Pro enables dense coverage of object surfaces. It accurately reconstructs fine details in one scan, significantly reducing repeated passes and streamlining workflow for precision metrology and reverse engineering. H1 Pro offers a stable and responsive real-time preview. It provides precise motion tracking for smoother scanning of complex parts, ensuring highly efficient field operations. Built-in AI algorithms enable a rapid point cloud processing. For the same volume of scan data, point cloud optimization, fusion, and meshing efficiencies increase by 10 times. Significantly reducing processing time and enabling seamless workflows across reverse engineering, quality inspection, and product development. Processing massive point clouds with high-speed precision beyond basic imaging chips, providing professional computing support for industrial 3D scanners. Equipped with an industrial-grade high-precision optical system, VoxMeta H1 Pro delivers 0.050mm metrology-grade accuracy to faithfully reproduce every detail for inspection, reverse engineering, and high-end manufacturing, helping improve quality consistency and minimize production rework. As a physical reference, the scale bar fundamentally reduces the stitching drift and environmental cumulative errors, delivering truly stable metrology-grade accuracy for large-scale workpieces. With AI-based mesh feature extraction algorithm, H1 Pro enables precise reconstruction of complex geometries, including holes, curved surfaces, irregular shapes, sharp angles, and vertical angles. Powered by advanced optics and algorithms, VoxMeta H1 Pro ensures stable data capture across various materials and complex geometries, delivering consistent accuracy and seamless data integrity. It meets the rigorous standards of high-end manufacturing, precision machining, automotive and aerospace industries, and mold development. Unlike systems that rely on external wireless modules, H1 Pro integrates wireless into a single device, right? So, and here we have our final result, just the beautiful, beautiful result here we have. Just check it out, guys. Just how beautiful it looks. A perfect scan if I have ever seen one. Just look at this. All the small minor details. Everything looks perfectly fine. Alright, so as I mentioned before, you can see we have applied this mark it on the wrong spot, so it caused a hole here. So what you want to do is just simply remove it from here, from this spot, and just put it to another place. Let me do it right now so I don't miss this chance. Okay, I just removed it, and now let's check it out. How beautiful it looks, how accurate everything is presented. You see these small writings are very crystal clear, and this logo, just a perfect scan. Now you're just gonna go ahead and export it out as an STL or OBJ PLV file and put it into any CAD modeling program for further processing, whether it's inspection, quality inspection, reverse engineering, or any other purpose. All right, now we have finished with our third case. So what do you guys think about this one? It looks perfectly fine for me. I like it. I'm super satisfied with the results. Now we can move on to our first case. We have a baker named Paul. My usage of H1 Pro will be mainly personal, but I may use it for some paid work. I'm particularly interested in using it for automotive reverse engineering, data archive of vehicle parts for future reproduction or restoration. I would like more information as to whether it could be automated into a system or remotely operated. I would like to see more tutorial on the use of VoxMeta software, its features, etc. You may already have covered this and I missed it. Yeah, you have mostly covered all of these options already, but today we're doing it again for you guys specifically. So we're gonna remove this tire from here. Oh yeah, we have a question here that says, will VoxMeta have a website shop for consumables and accessories? So we have a website that's called VoxMeta3D.com. Related accessories and consumables will be available on the official website in the future, so please stay tuned. All right, the next question. When scanning a full vehicle, is it possible to scan as one item or must multiple scans be stitched? If so, what is the minimum number of scans to be stitched? So when you're scanning the whole car, what you want to do is you can scan it just on one going. You don't want to scan all the parts separately, right? So if you want to scan the whole car, you can start scanning it and finish it by scanning the whole object itself. You don't want to scan it one by and then stitch them into one. So now we have a torque link here. Guys, check it out. We have torque link here. Paul plans to use the H1 Pro for automotive reverse engineering and to build a digital archive of vehicle parts for future reproduction or restoration. A part like this torque link is a good example because its function depends on more than the outside profile. The holes, edges, mounting areas, and the spatial relationship between those features are all matter. We'll capture the overall shape first and then concentrate on the holes, connection features, and recessed areas. For this object, we will use our turntable here so we can easily rotate it and capture it from different angles. So let's get started. For digital archiving, we recommend keeping the original scan data as well as the processed mesh. The original data preserves more options for future measurement or reconstruction, while the mesh is convenient for viewing, sharing, and downstream processing. If that's clear, let's move on to parameters. So point spacing, let's still use 0.25 because we have some small details on the surface we want to cover. So let's keep it like this, and we start from scanning the markers. All right, let's capture the markers. So in this case, first we're gonna be scanning using 34 crossline laser mode, and for the complex parts we can switch to single laser mode, so we can capture the hard to reach spots. Right, you can see that we have almost instantly covered practically the whole body. Let me change the zoom position. So you can see here we have some holes that are not easy to reach by using 34 crossline laser mode. Alright, so we have almost finished with this one. I think that I don't even have to switch to another scanning mode because we have already captured everything we needed. Let's finish it and check it out. Okay, so this is the result we achieved with 0.25 point spacing. Let's go clean it up. All right. And let's go mesh it up. And you can check it out. You can check it out. Another beautiful scan. No holes, no issues. Everything looks perfectly fine. Alright, so this was the torque link. Paul also asked whether the H1 Pro could be integrated into an automated scanning system such as a robotic arm or fixed scanning setup, and whether it could be operated remotely from a workstation. The H1 Pro can be integrated into this type of automated system with dedicated software and system integration. In an integrated setup, the scanning process can be controlled from workstation to support automated operation. For individual use, scanning can be started or paused through the VoxMeta software on the computer or directly from the scanner itself. So this was our fifth use case. You can check it out. Also, you can leave on the chat how would you evaluate this one. And now we're moving on to the next use case. We have here Justin, our baker. He says, "Hi, I gotta say, however, this turns out you guys have run the best Kickstarter on all ends I've ever seen." Oh, thank you for that one. Likely use is going to be a small to mid-sized or reverse engineering projects to be printed using engineering filaments. Could be as simple as covering for PCBs, hinges, or still small to mid-sized, small two-stroke engine components, motor housing, things like that. For me, not like a car engine part or full car door. Thanks again. You're welcome, Justin. In your case, we have another object. So we have this cylinder here. Check it out. This one is a very difficult object. You can see they got a ton of geometries, holes, curves. So we'll try to scan this one out. Justin plans to use the H1 Pro for small to medium-sized reverse engineering projects, including two-stroke engine components, motor housing, PCB covers, and hinges. This cylinder is close to the category in both scale and mechanical complexity. The H1 Pro provides 3 laser scanning modes for different types of geometry. I already covered that part. So for this cylinder, we'll use the cross laser mode to capture the overall geometry efficiently. If you need to capture a deeper or narrower area, we can switch to single line mode. So let's just jump into it. For this object, we're not going to be using 25, we're going to be using 0.50, and we start scanning the markers. Alright, now that we finished scanning markers, we can long press on play button and double tap on M button. Let's zoom out and optimize our exposure level to 1.5 and start scanning and see how it goes. Alright, this one is going to take a little some time due to its complexity. Alright, you can see this one is quite a tricky one. So and we have this part that is not scanned yet. We can capture this. right, almost there. Now we can finish the scan and check out the results. On the preview, I can already see it is a very complete scan. All right, let's mesh it up and check what we can get. Powered by advanced optics and algorithms, the H1 Pro ensures stable data capture across various materials and complex geometries, delivering consistent accuracy and seamless data integrity. So, you can see we have finished with the meshing, and check it out, guys. Once again, it didn't let us down. As is expected, we have fantastic results here. This is what the H1 Pro delivers to you. The industrial grade 3D scanner proves its name. You can check how accurate, beautiful it looks. If you want to get even more details, you can increase the point spacing to achieve even better results. But I'm super excited and super satisfied with this result already. You can check it out and leave your assessment on the comments. Mechanical components often combine broad surfaces, precise edges, holes, and deep or narrow geometry. The three scanning modes allow the operator to adapt the workflow to these different structures on the same part. So you guys check it out. Here. As I said before, if you want to reach a better results, you want to take your time and capture it a little more longer. We just simply fastly ran it over. Fast coverage. So yeah, this is it. Now we can move on to our sixth case. That is biggie rights to us, personal DYD first, scanning and later producing objects, CNC or 3D printer. Second, the everyday household items that tend to break, bend, etc. Plastic, wooden, metal parts that can be scanned with an accuracy and completeness of reproduction. Also, Yilin says, I plan on using the device for personal DIY at first and hopefully for commercial use in the future. I will use it to repair broken components by replicating the original part and then manufacturing a replacement. I also would like to offer fee-based 3D scanning services. All right, perfect. Now for this case, we will move to a smaller parts. We have some 3D scanned objects here. That is the screws. You guys can check it out. We have three different sized screws here that we can scan. So we'll try to scan them out and see what we can get out of it. All right, let's start from this one. Let's start from the bigger one. So Biggie plans to scan everyday plastic and wooden and metal parts so they can later be reproduced through CNC machining or 3D printing. Yilin also wants to repair broken components by scanning the original part and manufacturing a replacement. The H1 Pro can use its single-line scanning mode where local details matter while its accuracy of up to 0.050mm supports measurement and reverse engineering work. Before we begin, you can see the scanning mode, exposure, and point distance settings we are using for this part. Alright, let me create a new project. For this one, we're gonna be using the single laser mode. So let me quickly as you can see, we're currently using the single laser mode. I joined late, but in a message to me you mentioned small screws scans. It has that been done yet? About the screws, no, you're welcome. We just start scanning the screws, so you just came in perfect time. You can join us and stick to us so you can check the final result with us together. So right now I'm scanning this screw. This is M16 size, I guess. So we have M12 and M18. So now I'm using 0.5 accuracy, point spacing. Right, so we'll try to capture everything here. Alright, so this is the screw we have scanned. Let me remove. And now we have a clean data. Let's mesh it up and check it out. Here you can see we have a beautiful result. Right, so this one, this was a lower resolution. Let's put a higher resolution and check if we can improve the result. Say 25, and we're gonna be using a smaller screw I have here. Let's go check it out. Let me zoom in. You see the head of the screw has some texture, and so we are being able to capture even that texture. Alright, so this is the high resolution scanning. Now let's remove the plane. So we have this one, you want to press Ctrl, clean it up, let's go meshing, and here you have the results. So here we have Isabella saying it performs pretty well, better than the scanner I have in my hand. Thank you for complimenting. We're happy to provide such a high quality product. If it's not a problem, you can mention what kind of scanner are you using currently. All right, now we can move on to even higher point resolution and try to scan this smaller object. Here we have this is M12 size screw. Let's see how our scanner will handle this one. So you can mention in the chat what kind of project are you guys working on currently, or what you guys are planning to use the H1 Pro 4 if you have already placed your order. All right, we finished with this one. Let's check it out. Naturally, we have even better and clearer result. Let's clean the data up and mesh it. See what we will have in the end. And here you have a perfect scan. Just check out the texture. surface, also this one, this part. Just a beautiful, beautiful scan. You can see how accurate it looks. So this was the power of the single laser mode. For replacement part workflow, scanning is the first step rather than the entire process. We first capture the surviving geometry of the original component. The data can then be cleaned and measured, and damaged or missing areas can be rebuilt in CAD before CNC machining or 3D printing. This approach is especially valuable when the original drawing no longer exists or the part is no longer in production. The H1 Pro turns the physical component into a digital geometric reference, giving the engineer or maker a clear starting point for replacement. So we have finished with the screws, guys, and if you have any questions, you can ask in the chat. Now we can move on to our last object for today, that is car door. Yes, we have entire car door in our possession. So we'll use it to scan and show you. Here you have it, guys. Check it out. Entire car door. Let's scan and see what H1 Pro can do with it. It's quite a big object. So point cloud, we're gonna go back to 5. Start scanning from the markers. Let me zoom out. I'm sure most of you guys are interested in automotive auto parts. So this is a good example. This is an entire car body door. All right. Let's start scanning. Not the single laser mode. We're gonna use 34 crossline laser mode for fast capture. You can see how easy it is for our device. So we're almost done with this part. right. We have a question on the Facebook. How important is a clear backdoor and lighting with this scanner? I have mixed results with my scan due to lighting with single laser. Alright, so we have finished the scan of the door. You can see how clean it is. Let's remove the plane here. We can manually choose the plane and remove it. Also clean it up. Let's clean it up and see. All right. And let's mesh it up. We have a question on Facebook. So someone says, we are planning to scan knives and guns to engrave with a fiber laser. That's a great use case. H1 Pro can scan metal parts, and scan data can be used for design and laser engraving. For reflective surfaces, adjusting the exposure can help improve the data quality, right? So now we're getting our meshed result. Let's check it out. It's almost done here. All right, here it is. You can check how accurate the scan data looks. So any other use cases you guys want to mention, can ask in the chat. So when the big markers are having problem, you can use smaller 3mm markers instead of the 6mm markers. Sometimes it's too big for some parts, for some spots. So you rather want to use a 3mm scan. All right, so this was the front side of the car door. Also these screws, you can see. These are the glue parts that is not being able to scan out. It is completely okay. You can check on the real item. There we have black glue here, so that's why it's not scanned. Other parts are pretty clear. This part also, due to the fact that there is a glue there, plastic glue, so you're not being able to scan it. Other than that, also this spot, other than that, we don't have any issues with this one, with the scan. So looking at all these use cases, we can say that our bakers are not simply looking for a scanner that produces a good looking model. They want usable geometry for automotive reverse engineering, digital archiving, mechanical part reconstruction, inspection, replacement part production, CNC machining, and 3D printing. Today we use 7 different objects to show how the H1 Pro responds to-dos needs, blue laser scanning for challenging surfaces, fast coverage for larger parts, accuracy up to 0.50 millimeters for engineering detail, 3 laser modes for different structures, and flexible scanner and workstation control for practical operation. So we have some questions here. So we have question here, how important is a clear backdrop and lighting with this scanner? I have mixed results with my scans due to lighting with single laser. The H1 Pro's blue laser is less sensitive to ambient light, though we still recommend avoiding strong direct sunlight or very bright reflections. Under normal indoor lighting, scanning is generally very stable, as you can see in this case. For outdoor scanning, you can also increase the exposure to improve the scan. We've shared videos on our live stream replace of the H1 Pro scanning outdoors, and the results have been consistently stable. You can check them for evidence, right? For reference. You can check on our previous live streams. Also in the chat, someone asks, how important hello, can you talk about how to scan with your scan scale bar? Any tips on correct positioning? Also scale bar, using scale bar, you want to use scale bar when you have objects exceeding 1 meter long. So you want to put the scale bar for usage after scanning the markers. You can remove the scale bar. This way you can improve the accuracy, right? And then after scanning the markers, you can simply remove the scale bar and keep scanning the object itself. Here we have this door, a very beautiful scan. If you have any remaining questions, guys, you can ask in the chat. We're very happy to answer to you. So the right workflow still depends on the part and the final goal. We have today's demonstration gives you a clear idea of how to choose the scanning approach and what you can do with the results data once your H1 Pro arrives. We're looking forward to getting the H1 Pro into your hands and seeing how you use it in your own projects. So regarding the scale bar usage, we have a scale bar here. So for example, if you want to use it for this car door, right? So you want to find the best possible position. You want to apply the sticks here. You want to use the glue and glue it up like this. Let's say after you go to your software, you scan the markers with this scale bar, and then after scanning the markers, you just simply remove it, put it aside, and just keep scanning the object, right? So this is simple, very simple usage. So if you have object, you have the scale bar, you want to apply glue here on a stick. If the object is lying on the ground, or it doesn't, you don't have to put it this way. You can just keep using it without any glue, but in this case we recommend to use it with a glue in order to achieve a better result. So yeah, this is how you use the scale bar. So if you have any questions, you guys can ask. Otherwise, we'll be finishing today's live stream. We're looking forward to getting the H1 Pro into your hands and seeing how to use it. Use it on your own projects. Stay tuned for more product updates, software tutorials, and application focused live streams, live demonstrations. So if you have any questions, you guys can ask. We're very glad to answer to you.我就知道他会问这个。 Any questions, guys, you can ask in the chat. So regarding the glue, what type of glue you want to use? We're using 502 super glue here, but you don't have to use the same adhesive. As long as the scale bar stays firmly in place, it doesn't move during the scan, it's fine. Double-sided tape, removable adhesive, reusable mounting putty, or even magnetic fixing can also work and may be easier to clean afterwards. Okay, regarding when are you hoping to ship the H1 Pro? The H1 Pro is expected to be shipped next month. For more details, please see the description on the Kickstarter page. No, you heard it right. Yeah, that I told about the glue, so you did not mishear. So regarding the glue, we already answered to you. I hope it was clear. So we are using 502 super glue, but you can use, you don't have to use the same, you can use a similar or any other means of sticking our scale bar to the object. Yes, well, the next question, when you scan marker on table, can you tell the table not to scan it before scanning? Then it would get less information. That's a good question. Let me quickly demonstrate to you how that works, right? So let me remove this door from here. This is a question that can be easily answered. So let's say we have this plane. Let's say we have this table, right, with the markers on it. So you want to quickly scan the markers. After that, you exit it, complete. You go removing the plane. You choose the plane. You just simply remove it. And then you can just scan the object on the surface. You don't gonna be scanning the plane. So this way you can process less data. So I guess this was the last question for today, guys. So if you guys can subscribe to our channel and wait for our next live streams. We're gonna be saying when we're gonna have the next live stream. So stay tuned, guys. Thank you again for supporting the H1 Pro, and see you in the next video. As we know, manufacturing precision and quality are often compromised by factors such as component deviations, fixture stability, welding deformation, and human error. H1 Pro delivers an incredible 120 FPS and 4.4 million points per second in wired mode. When used with a scale bar, it achieves a volumetric accuracy of 0.050 mm plus 0.02 mm per meter. This ensures an industrial-grade precision even for large-scale projects. But how does it perform wirelessly? Let's find out. Now we'll process a scanned model and check the results after mesh. This is the deviation map of the car side frame in Control X. Most areas are within tolerance, with only minor deviations visible. What do you think? Let me know in the comments.